Today we're going to be reviewing exponents and polynomials. Before you watch this review lesson, please go and take a look at the notes that are included on the Google Classroom with the rest of this material because they go over the vocabulary that we learned in the polynomials unit, and it goes over also the exponent laws or exponent rules that we learned. So let's take a look at our first example. So in our first example, we want to express our answers as a single power with a single positive exponent, and then we want to evaluate. So our first one, 1a, we have negative 2 to the power of 5 times negative 2 to the power of 2. Now when we're multiplying, we want to add our exponents. So we end up with negative 2 to the power of 5 plus 2. That gives us negative 2 to the power of 7. And if we evaluate that, we get negative 128. So that negative 2 to the power of 7 is expressing with a single positive exponent and as a single power. Let's go to 1b. We have negative 3 to the power of 4 divided by negative 3. Now notice that second negative 3 does not have an exponent on it. That does not mean that our exponent is 0. It means that our exponent is 1. So I'm going to write that in there for now. So whenever you don't see an exponent there, it's a 1. When we are dividing, we want to subtract our exponents. So we end up with negative 3 to the power of 4 minus 1. That gives us negative 3 to the power of 3. So we're expressing as a single power or with a single positive exponent. And now we're going to evaluate. So we're calculating this. And that gives us negative 27. Now notice for A and B, we had negative numbers, we had brackets around them. And that is because we want to make sure that that entire negative number is then raised to the exponent. So for example, if we have negative 2 in brackets to the power of 2, that is going to be negative 2 times negative 2, which is going to give us positive 4. Now, if we have negative 2 without a bracket and then to the positive 2, that is the same as having a negative out in front and then just positive 2 squared. And positive 2 squared, that would give us positive 4, and then we would just be throwing that negative there in front of it. So those are two different situations, and so you need to make sure you take note as to whether there are brackets around that negative sign or not. Okay, let's move on to 1c. So we have 5 to the power of 3, and then all that is to the power of 2. So you can see that there's multiple sets of brackets here. So this is the power of a power rule. And when we have power of a power or exponent of an exponent, then we want to multiply our exponents together. So this is going to give us 5 to the power of 3 times 2. That gives us 5 to the power of 6. And now we're going to evaluate, and we get 15,625. Now for part D, we have another division question. So we have 19 to the power of 45 divided by 19 to the power of 45. So we're going to be subtracting the exponents again. So we're doing top exponent minus bottom exponent. So we have 19 to the power of 45 minus 45. They're the same in this case. That's going to give us 19 to the power of 0. Now any number that has an exponent of 0 is equal to 1. And I should say any number or any variable. So let's write that down. Any number or variable with an exponent of 0 is equal to 1. Okay, let's move on to our next set of questions. Now we're still using our exponent laws or exponent rules, but we are going to be simplifying expressions that have variables in this case. So in our first one, so 2a, we have 4x to the power of 5, y to the power of 6, times negative 5x, y to the power of 3. So notice that this x has an exponent of 1. And what we're going to do is we're going to start off by multiplying the coefficients. So the 4 and the negative 5, those are coefficients. So we're going to multiply those together. Then we're going to be multiplying our x's together. And when we do that, that means that we are adding the exponents. So we have x to the power of 5 plus 1. Then we're going to multiply our y's together. So we have y to the power of 6 times y to the power of 3. And we're going to add our exponents. 4 times negative 5 gives us negative 20, and then we have x to the power of 6 and y to the power of 9. And that's our final answer. We're not given values for x or y, so that's just where we leave it. Okay, let's move over to B. We have 75 times x to the power of 8 times y to the power of 3 divided by bracket negative 5 times x squared times y, close bracket, all of that to the power of 2. Now here we need to make sure we follow BEDMAS. And what I mean by following BEDMAS is your order of operations. So that means we're going to be doing exponents before we do any division. So we're going to have to deal with the second chunk, that negative 5x squared y. We're going to have to deal with that first. So when something is squared, so I'm just going to first write down that first chunk, that we're not using just yet. So when something is squared, we are multiplying it by itself. That means that negative 5 is being times by itself. Right, so we have negative 5, notice I have the bracket there, squared, and then we have x squared, and I'm going to stick another little 1 in there with that y, and then we have times y to the power of 1 squared. So we've applied that exponent of 2 to everything that is in the bracket. So negative 5 squared gives us positive 25. X to the power of 2, then also to the power of 2 again. We multiply the exponents. 2 times 2 is 4. And then with the y, we have 1 times 2, which gives us 2. So we have 75 times x to the power of 8 times y to the power of 3 divided by 25 times x to the power of 4 times y to the power of 2. So now we're going to deal with the coefficients, which is 75 divided by 25, and then start dealing with the variables. So we have x to the power of 8. We're using division, so we're going to subtract, minus 4. And then we have y to the power of 3 minus 2. 75 divided by 25 gives us 3. And then we have x to the power of 4 and then y to the power of 1. So we don't need to write that exponent of 1 in our final answer. Okay, next up we have division happening, we have multiplication happening, and we have an exponent happening. So first thing I'm going to do is just point out that we have a little silent exponent of 1 there on that first x, and we're going to again be following BEDMAS. So that means we need to deal with the exponent first. So on the numerator position, we just end up with 3x and then to the power of 1 there. And now we are going to apply that exponent of 3 to all the parts of that term in the brackets. So negative 3 cubed, x to the power of 4 to the power of 3, times y to the power of 5, and then to the power of 3, and all that is over 9x squared, y to the power of 6. So let's apply those actual exponents. Negative 3 to the power of 3, that's going to give us negative 27. And then we're going to end up with x to the power of 12 because of the 4 times 3, and then y to the power of 15 because of the 5 times 3. All of this is divided by 9x squared, y to the power of 6. So now we're going to do 3 times negative 27. That's going to give us negative 81. We have x to the power of 1 times x to the power of 12. That gives us x to the power of 13. And then we have y to the power of 15. And all that over 9, x squared, y to the power of 6. So now we only have division left. Negative 81 divided by 9 gives us negative 9. X to the power of 13 divided by x to the power of 2, that's going to give us x to the power of 11, because 13 minus 2 gives us 11. And y to the power of 15 divided by y to the power of 6, that's going to give us y to the power of 9. And that is our final answer. Okay, let's move on to our next section. And in our next section, we're going to be looking at our like terms and expanding and simplifying. So in our third example, we're going to be simplifying by collecting like terms. And just very quickly, like terms, let's zoom in a bit. So like terms are those terms that can be added or subtracted together. Okay, and if you haven't already done so, make sure you read the notes and go over the notes document or notes file that was included with this lesson before you continue on with the video. So simplifying means that we are going to do some adding and subtracting, and we're going to make sure that we're only doing this with like terms. So we're going to start off by grouping together our like terms. I'm just going to use shapes. So in our first expression here, we have 6x plus 4y minus 9 plus 7x minus 11. So anything with an x and an exponent of 1, those are like terms. So I'm putting a blue box around them. Now we only have one term that has a y in it. Okay, so we have that positive 4y or plus 4y. And then we have two constants, so just numbers. So here we have a negative 9 and a negative 11. So I've tried to group together the like terms. I'm now going to write them beside each other. So 6x plus 7x plus 4y minus 9 minus 11. Notice that when I was doing the squiggly line or the circle or the box, I was including the sign in front of it because that goes together. That includes the whole term, includes the sign in front of it. Okay, so now we can add or subtract our like terms. So we have 6x plus 7x, that gives us 13x. We just have 4y by itself here, and then we have negative 9 minus 11, which gives us minus 20. Okay, and we're all done. That's it. We can't go any further. Let's try our next one. So for part B, we have 2 plus 4x minus bracket 3x minus 8. Now, what we need to recognize here is that we have a negative sign in front of a set of brackets. So that means that this negative sign is going to change the signs of the terms in the brackets. So let's quickly write that down. So subtraction sign in front of brackets will change signs of terms inside the brackets. Okay, so keeping that in mind, I am now going to kind of rewrite this expression. So we have 2 plus 4x, and now we're going to change the signs of what's in the bracket. So instead of a positive 3x, we're going to have minus 3x. And now instead of a negative 8 or a minus 8, we're going to have a plus 8. Okay, now I'm going to go through and I am going to put a box around my constants. It doesn't matter what shape you use or color or whatever, you're just grouping things together. And then I will put a circle around my terms that have an x. And I'm going to rewrite them beside each other. So 4x minus 3x plus 2 plus 8. And 4x minus 3x, that gives us 1x, or just x. You don't have to write the 1 in front of it. And then 2 plus 8 gives us 10. So there's our final answer, x plus 10. Now, I haven't used any variables that have an exponent other than 1, so I just want to do a quick reminder here. But again, this is in the notes. If you look in the notes, if we have like x and we have like x squared, they are not like terms. Okay, so that's just, let's remember that they need to have the same exponent as well. Okay, our next set, we are going to expand and then we're going to simplify. So the word expand, this means multiply. So we have to do some multiplying before we simplify. And simplify, again, just means to collect your like terms like we did right above. And what we're going to be using to do this is called the distributive law. So at its simplest, the distributive law is basically A times B plus C is equal to A times B plus A times C. So this is something that you would have seen going back to grade 8, maybe even grade 7. So let's look at 3a, 4a. We have 3 times x plus 9, which are in the brackets. So that means that everything in the brackets, these two separate terms in the brackets, need to be multiplied by the 3. Okay, if we follow our distributive law. So we have to expand. So we have 3 times x plus 3 times 9. 3 times x gives us 3x. And 3 times 9 gives us 27. So we end up with 3x plus 27. Now we've expanded, and can we simplify? No, we can't simplify any further because we don't have any like terms. Let's go and do the same thing for b. So we have negative 2x times 4 minus x. So we're taking this negative 2x and we're multiplying everything in the brackets by that negative 2x. So we end up with negative 2x times positive 4 plus negative 2x times negative x. Okay, remember the sign in front goes with the term. So negative 2x times 4 gives us negative 8x. And then we have negative 2x times negative x. That's going to give us a positive 2x squared. Again, there's no like terms, so we're all simplified. But proper form is to put the term with the higher degree variable in front. So we're just going to switch spots here, but notice that the signs stay with the term. Okay, let's do one that is more challenging. So for part C, we have negative 4x times 5 minus 3x plus 3x times 2x minus 1 and then minus x squared. Okay, so we have to do distributive law twice here. So that is going to give us negative 4x times 5 plus negative 4x times negative 3x plus 3x times 2x. I'm going to have to zoom out in a moment. Plus 3x times negative 1. And I think I can squeeze it in, minus x squared. Okay, so we're actually going to multiply everything out and then we're going to simplify by collecting like terms. So we end up with negative 20x plus 12x squared plus 6x squared minus 3x and then minus x squared. So we have two different types of terms here. We have the terms that have the x squared and the terms that just have the x. So I'm going to put a box around the terms that just have the x. I'm going to put a circle around the terms that have the x squared. And of course, you don't actually have to do this. This is just to help those of you who need a little bit of a refresher on collecting your like terms. And then we have 12x squared plus 6x squared. I'm writing those in front because we're going to try for a proper form here, like we just talked about in part B. And then we have minus 20x minus 3x. That is going to be equal to 17x squared minus 23x. And that is your final answer.